Upon logging into Fort Sentry, we'll first see the dashboard. The dashboard provides a summary of the current state of privilege creep across your environment's authorization systems. An individual AWS account, GCP project, Azure subscription, or VMware host represents a single authorization system. In this case, we're looking at one of our environment's AWS accounts. The prominent pane in this dashboard is an account-level roll-up of the privilege creep index, which is a single data point scaled from 1 to 100 that quickly tells us the level of privilege creep risk associated with a given environment. We calculate the privilege creep index by looking at the total set of all permissions available to a given identity, as well as the number of resources, VMs, buckets, etc., that an identity can take action on with those permissions. We compare this to the number of permissions and resources touched by that identity in the past 90 days. If an identity has broad access, but is only using a small fraction of its permissions against a small fraction of accessible resources, it will have a high privilege creep index. In the dashboard, we see an aggregate view of the privilege creep index for this entire AWS account. In this case, we can see that we have a privilege creep index of 93, which is quite high. To the right of this, we see a distribution map of the privilege creep indices for all the identities in this account. From this chart, we can see that the majority of identities in this account have a privilege creep index of 1, meaning they are right-sized to least privilege access. That's pretty good. However, we also have 8 identities with an index of 100, and that's driving up the account-level privilege creep index. Right below this pane, we also have the privilege creep index trend. This will show how the index for a given environment is changing over time. Once we start remediating some of our overly permissive identities with CloudKnox, we should see this trend downwards. At the very bottom of the dashboard is the usage analytics summary, which gives us a few more insights into the proliferation of high-risk permissions in our environment. We classify high-risk permissions as any that could potentially cause service disruption, service degradation, or data loss. As an example, the ability to terminate an EC2 instance or change an S3 bucket's public access policy in AWS would constitute high-risk permissions. The beauty of this dashboard is that it gives us a single, consistent metric to evaluate privilege creep across all of our environments. I'll see the same data representation whether I'm looking at an AWS, GCP, Azure, or VMware environment. Next, let's go to the usage analytics page. From here, we can dive deeper into the data for all of the identities in a given authorization system and take a look in detail at individual human or machine identities. To start, we're looking at a list of all of the user identities associated with this particular AWS account. Each identity has its own privilege creep index. For example, we can see that Ravi has a privilege creep index of 100. Why? Well, he has 9,411 tasks or permissions available to him in this particular AWS account, and he can use those permissions to affect 1,100 different resources in the account. Despite this, in the past 90 days, he's only executed 74 permissions against 47 resources. That's a lot of unused permissions and a lot of unnecessary risk in the environment. If we click on Ravi's row, we can see a breakdown of what permissions in particular are actually being used by him. This pink S next to Ravi's email tells us that this is a SAML identity, so we are also able to see which roles in this account that Ravi is able to access from his SAML heartbeat identity. It looks like a role called CK SAML Power User is available to him. When we click on this role, we see exactly what policies are attached to it, and as we can see, there is an AWS CIEM policy attached to this role that provides unfettered access to the AWS account. CloudKnox is intelligent enough to show an aggregate view of all of the permissions available to an identity, even when that identity indirectly accesses those permissions, such as by assuming a cross-account role in AWS. We're almost done picking on Ravi for now, but there's one other thing I'd like to show you first. If we click on Ravi's email, we're taken to another window where we can explore his access in even more detail. Because this is a SAML identity, we can use the drop-down menu in the top right to explore all of the authorization systems that he has access to in our multi-cloud environment. For instance, if we switch to this GCP project, we see a breakdown of Ravi's permissions in this specific environment, as well as a list of the GCP-specific IAM roles that are providing him with this level of access. We've heard from our customers that the ability to trace a SAML heartbeat identity across a multi-cloud environment like this is one of the bigger value adds they realize with the CloudKnox platform. In addition to user identities, we can also explore the various non-human identities in our environment to see if there's any privilege creep associated with them. In the context of AWS, we can use the filter on the left side to just look at our IAM roles. In AWS, some IAM roles are meant to be assumed by users. We see the CK-SAML power user role from earlier in this list. However, other roles might be used by non-human actors, like EC2 instance roles. We'll click on this Knox security role to get more detail. As we can see, this role is presently associated with 2 EC2 instances in our environment. Aside from this, we can also pivot to AWS access keys to see the proliferation of keys and associated privileges in our environment. In addition to the privilege creep index for each key, we can also see some key-specific information, such as the number of days since a given key's last rotation. By expanding one of these rows, we can see a chart that shows the days and times that the key has been used. This is useful for visualizing keys that are used in scheduled jobs at regular intervals, as an example. One big generator of non-human identities is serverless functions, such as AWS Lambda. Each Lambda function has its own execution role, a special kind of IAM role that is used by the function during execution. Lambda functions should only require discrete and focused access, so you can use the serverless functions pane of the usage analytics screen to look at these specifically and see if any need remediation for least privilege. Besides these AWS-specific entities, we also support the platform-specific machine identity constructs that exist in Azure and GCP. From the usage analytics screen, we can dive into data associated with our GCP service accounts or our Azure app and service principals, like we see on the screen here. Lastly, we can also see a resource-centric view of access by clicking on Active Resources in the dropdown. Here, we can see a complete list of resources that have their own access policies, such as AWS KMS keys and S3 buckets. If we click on a resource like this S3 bucket, we can see all of the identities with access to it and all of the identities that have actually accessed it within the past 90 days. We also see a breakdown of all possible permissions usable against this resource and those that have actually been used in the past 90 days. If we click the resource name, we see a complete list of the identities with access, human or not. We'll take a closer look at this identity, and we can see that this is a local user in the AWS account, denoted by the blue L. Clicking on the identity, we get a map that shows exactly how it gains access to the resource. In this case, membership in the SSH access group provides the read-only access policy to this user, providing read access to the S3 bucket. If we click on the group, we see it expand so that all of the users with access via the group are shown. Each one of the identities that we've seen so far in this Explorer, human or not, across all of the different cloud environments, can be remediated for activity-based least privilege from within the CloudKnox platform.